Okay, example 2, graph on a number line, x squared minus 2x is greater than or equal to 3. So, first thing, the last problem already started off factored form, inequality 0. It's very, very important we want inequality 0. We don't want inequality 3 or anything else like that. So, always when you're doing these things, always get everything to one side first. So, I'm going to do x squared minus 2x minus 3 is greater than or equal to 0. Always start off there. We're only going to be doing quadratic stuff in this class. We're not going to be getting into cubic or anything weird like that. So expect it quadratic at worst. All right. With the quadratic trinomial, we'll look for a factored form. So x minus 3 times x plus 1 is greater than or equal to 0. All right. So that's priority 1. Get everything to one side with 0 on the other. Factor the quadratic trinomial using whatever factoring techniques is necessary. And that creates, for me, answers that make 0. So x minus 3 equals 0 if x equals positive 3. X plus 1 equals 0 if x equals negative 1. Those two numbers are important because they're going to help me create my intervals. Okay, so always start off with solving the quadratic inequality, or quadratic equation, I should say, for 0. Anything that makes, any x that makes the whole thing equal to 0 is important. Then we make our intervals up, so negative infinity with a parentheses, always parentheses on infinities. And the first number I get to along the number line as I go from the left to the right is going to be negative 1. And negative 1 I'm going to bracket because this says greater than or equal to. Okay, so every number that I get along the way is going to be a bracketed number. My second one is going to go from negative 1 up to 3, bracketing both numbers. And my third one's going to go from bracket 3 up to infinity, and infinity is going to get a parentheses. So again, 2 zeros created 3 regions. I need test points for each region. Anything between negative infinity and negative 1 will do. I'm going to go negative 2. Between negative 1 and 3, I'm going to pick 0. Between 3 and infinity, I'm going to pick 7. Just to be weird, I'm going to pick 7. Right. I would normally pick 4, but it's just being crazy today. All right, so we're doing products. What I care about is signs, not numbers. So, if I put negative 2 in here, negative 2 minus 3 is negative 5, negative 2 plus 1 is negative 1. 2 negatives make a positive. If I put 0 in, 0 minus 3 is negative 3, 0 plus 1 is positive 1, negative times positive makes a negative. And finally, if I put in 7, 7 minus 3 is positive 4, 7 plus 1 is positive 8, 2 positives make a positive. Again, we're looking for greater than or equal to 0, which is positive. So the positive ones count, the negative one doesn't count. So I want to graph everything from negative infinity to negative 1, but this time notice our domain is a set of integers. So again, only graphing integers. Negative 1 is bracketed, so I'm going to put a closed circle at negative 1 because that's an integer. I'm going towards negative infinity, only graphing integers. So negative 2 is an integer, negative 3 is an integer, negative 4 is an integer, negative 5 is an integer, and then bracket. Or sorry, all the way to infinity. So shade in the arrow. All right. For the magenta one here, we're starting at 3, which is an integer and it's bracketed, so we include 3. And then we're shading to the right, only hitting integers, so 4 is an integer, 5 is an integer, and then all the way to infinity, so we shade in the arrow. And again, all the answer represents is numbers that fit the descriptions that are graphed make the answer true, make the problem true. If we try it out, just let's pick 7. There's 7 right there. If I pick x equals 7 and I put it in place of x here and here, it should make a true statement. X squared would be 49. 2 times 7 would be minus 14. It's supposed to be greater than or equal to 3. 49 minus 14 is 35. Greater than or equal to 3. That's true. Right? So all that's doing is we're graphing the answer where it's true. If I pick something that's false, like let's say 1, if I put 1 in for x, I'm going to get 1 minus 2 is greater or equal to 3. That's negative 1 greater than or equal to 3. That's false. We're not graphing the false, we're only graphing the true. So that's what we're finding when we do this.